Integration is the inverse of differentiation, and it's often called anti-differentiation. So integration so it's the reverse process of differentiating. Um, Now, to show this, consider the function f of x is equal to x squared plus 3x plus 4. Now, we know how to differentiate this function. This was our previous unit. So, we know that its derivative f dash x will be equal to 2x plus 3. And we can represent this in a diagram. So this is our original function, x squared plus 3x plus 4. If we differentiate it, we end up with a new function, basically, which will be the derivative of the original function, which will be 2x plus 3. Now, what you're saying here is the reverse process of differentiating. So the reverse of this process is what we call anti-differentiation. So anti-differentiation. So the opposite of differentiating is anti-differentiating. What you're interested here is actually this process here. Another name for this is integration. So from this diagram, we can summarize a few things here. We can say that the original function, so we can say that f of x is an antiderivative of the derivative function. So f of x is an antiderivative of f dash x, which is 2x plus 3. So the original function is an antiderivative of the derivative function. So simply we can say that f of x is an antiderivative of f dash x. Now that poses some questions that we need to investigate here. So the main question is this the only function whose derivative is 2x plus 3? So is this function is what I'm referring to. So is this the only function whose derivative is 2x plus 3. So what we're asking ourselves here is this the only function whose derivative is 2x plus 3? Well, let's try and inspect a few other functions before we generalize this. Suppose you have another function, say h of x, which is x squared plus 3x plus 5. Now, obviously, if we differentiate this, we'll end up with h dash x, which will be 2x plus 3. So h of x has the same derivative as the function that we had initially, which was x squared plus 3x plus 4, which means that h of x is an antiderivative of 2x plus 3. Okay, let's look at another one. So this is the first one. Let's look at another function. G of x is equal to x squared plus 3x. If we differentiate that, we'll end up with a 2x plus 3 again, which means that g of x is an antiderivative of 2x plus 3. Again, let's try another function, m of x, which is x squared plus 3x minus 70. The derivative of that is 2x plus 3. So again, we can say that m of x is an antiderivative of 2x plus 3. So we can actually see here infinite number of functions whose derivative is 2x plus 3. So we can summarize and say, we can summarize our result and say that there are infinite functions. So there are infinite functions whose derivative is 2x plus 3. And you can say, basically, these infinite functions, they have a general form. So you can add a statement and say, whose general form is f of x is equal to x squared plus 3x plus c. So that's very important. Of course, if you look at the first one, h of x, c is 5, g of x, c is 0, m of x, c is negative 70. So we are saying here that there are infinite functions whose derivative is 2x plus 3, whose general form is x squared plus 3x plus c. So in general, it's very important, we say that f of x, which is equals to x squared plus 3x plus c, and this is for this particular case, is an antiderivative of f dash x, which is 2x plus 3. So in general, we can say that f of x, which is equals to x squared plus 3x plus c, is an antiderivative of f dash x, which is 2x plus 3. So this is a family of functions.